Alrighty, good day, class. I have another video lessons for this week. I think, is going to end up wrapping up our triangle relationships, the things we're learning about triangles, in regards with their angles, focusing on the angle relationships with triangles. And so, if you're doing this on your own sheet of paper, please highlight the key information Please write down the key information that I have highlighted for you, and also make sure you have the diagrams on your paper as well. So, the title of this is Inequalities and Triangles. And so, when we think of inequalities, think of them just like when we did in algebra, when we're kind of comparing if something was like less than, okay, this is our less than, or if I'm comparing to like greater than, so that's our greater than symbol, okay, and, oops, sorry, and then we could have greater than or equal to, and if it's greater than or equal to, you have that little line, that bar underneath. So we are going to do some comparisons um, and think about some inequalities that could occur in triangles when we're comparing parts of those triangles, especially in the relationship of the angles. So the first one we're going to talk about is this exterior angle inequality. Now, um, exterior angle inequality is dealing with the exterior angle, and I kind of want to recap on that. So let me fix my font here. This angle 1 is your exterior angle, okay? That's our exterior angle. I'm going to abbreviate that. And our exterior angle has a relationship with our remote interior angles. And that would be angle 3 and angle 2. We call these the remote interior. I'm going to abbreviate interior with INT. And there's my interior angle symbol. So, right there. Now, the exterior angle theorem states, and I'm going to write it up here. The theorem, this is on the, I think of the first one we did here, but the exterior angle theorem states that whatever is on the outside of the triangle, the exterior angle, it is equal to, that's my equal sign, sorry, the sum, so that means you have to add, of your remote interior. Okay, so that's the theorem. If I know it takes 2 and 3 together, basically, to equal, so I'm going to write it up here. It takes the sum, so that means the measure of angle 2 plus the measure of angle 3. The sum of them will equal our angle 1, our exterior angle. Well, if it takes 2 of them to equal 1, if I'm comparing the exterior angle to just one of the angles, then it's going to be greater. So that's what this statement is here. If I have an exterior angle, it is always greater than the measure of its remote interior angle. So it's one exterior angle is greater than one remote interior angle. So that's our theorem, okay? Outside is greater than the one remote inside. I'm just comparing them. So in our first example here, they want us to explain why angle 1 is greater than the measure of angle 1. That's what that symbol means right there. The measure of angle 1 is greater than the measure of angle 2. So we're trying to prove why this outside exterior angle is greater than this angle 2 over here. So the way I would do that is use the exterior angle theorem. Excuse me. So I know this is the exterior. Angle 1 is your exterior angle. Well, I need to identify the remote interior. Your remote interior will be angle 3 and 4. Okay, so that's your remote interior. Now, the theorem we just said, that we just kind of went over, states that that exterior angle, the measure of my angle 1, that's the exterior angle, is going to be greater than, I'm going to do it this way, it's going to be greater than the measure of the remote, so the measure of angle 3, okay? So angle 1, the measure of angle 1 is greater than 3, and I guess I could show both, and that measure of angle 1 is greater than the measure of angle 4, because That was an angle, that was a remote interior angle as well. But I'm trying to prove that it's greater than angle 3. Well, what I know about angle 3 and angle 2, right, is that they're congruent. They're vertical. So I know that the measure of angle 2, I'll just write it right here. The measure of angle 2 equals the measure of angle 3. Now I can do a conclusion. I can make a conclusion using substitution. And I stated this in, I think, the last video. Therefore, these 3 dots that look like a triangle. Therefore, I can state that the measure of angle 1 is greater than the measure of angle 2. Okay, just by using substitution. And I could say if I needed to, by substitution. Okay, so we're going to always compare outside to your remote interior inside. Now, with this next example, we have to pay attention to these important markings right here, these arrows. Let's see if you remember what that indicates. Okay, well, it indicates that we have lines that are parallel. So if you need to, and I'm going to highlight to help you see, this horizontal line, all horizontal lines are parallel to each other. But what I wanted you to see as well is that we have a transversal here. We have 2 transversals. Okay, I'm just going to extend it so you can kind of see, because that's how I'm going to use that relationship to prove angle 1 is greater than angle 2. So I know my angle 1 over here is my exterior angle. And what I want to do is using the parallel lines, the transversal, okay, this angle 1 would be congruent to angle 2 and 3 because they are alternate interior angles. Okay, so it takes the 2 of them, the sum of 2 and 3, to equal angle 1. So that's one way I can use this. So I know that the measure of angle 1 equals the measure of angle 3 plus angle 2 because they are alternate interior angles. Okay. Now, if I also look at the other transversal that I have here, I have, let me go green on this one. I have angle 4. This angle 4 is also going to be congruent to angle 2 because it is also alternate interior angles. So the measure of angle 4 is equal or congruent to the measure of angle 2. We have alternate interior angles. Okay, alternate interior angles are congruent when you have parallel lines. Now remember, the exterior angle is larger than the remote interior. So 3 and 4 are your remote interior. 3 and 4. So I know 1 is greater than 4, right? So using the exterior angle theorem, angle 1 is going to be greater than the measure of angle 4. Well, I'm trying to prove angle 2, but I know 4 is congruent to angle 2. So therefore, I can make a conclusion here. The measure of angle 1 is greater than the measure of angle 2 by substitution. And you don't have to say why. We haven't talked about that yet. We're about to get into that with the next unit. I'm using properties to justify your statements. But I just substitute the 4 for 2 because I already showed that it's greater than 4 using the exterior angle theorem. And just substitute it and I can prove that 1 is greater than 2. Okay. Now you're not going to have to do things like this. We're just going to do some reasoning. But I am going to ask you to compare. All right. So if you look at the next 2 problems, and I just realized, I think on your copy you have your angle symbols here. Sorry about that, that didn't transfer in the PDF. So this is just showing the measure of these angles here. And so what they want us to do is they want you to determine if when comparing the two angles if it's going to be greater than, is it going to be less than, or are they going to be equal? Okay, that's all we're doing, fill in the blank way. So you have to look and read your diagram. So if I'm looking at angle 2 and I'm comparing it to angle 5, okay, angle 5 is the x here angle. So if it's the x here, it's going to be the bigger part. So that means that for comparing 2 to 5, 2 is going to be less than the measure angle 5 because 2 is the remote interior. Okay, let's try angle 1. If I'm looking at angle 1, if I look at here, angle 1 is your exterior angle. If I compare 1 to 4, 1 is going to be greater than. If it's outside, it's bigger. Okay, it's greater than the measure of angle 4. Why don't you try number 4 here, comparing. And I'll go ahead and pause. You can pause. Okay, so if you're comparing 5, I know there's 2 triangles here, but if I look, 5, this exterior angle, 5 is actually outside of this first triangle, this triangle, the yellow for me. So it's inside the next triangle, but if I'm comparing it just to the triangle at 1, 2, and 3, it's on the outside. So 5 is greater than 3, and then here 4 is inside the triangle compared to 7 that's on the outside. So that means 4 would be less than. All right, so on the next theorem this is where we're going to take those comparison of parts and identify the largest angle or the largest side. Okay. Excuse me, I'm sorry about this. So if you have two sides of a triangle that are not congruent, then your largest angle will be always opposite the longer side. So what I wanted you to see here is if I have, I think you can kind of see this because it's kind of drawn to scale, but XZ right here, this is the larger, or the largest if you want to take it. Okay, and what it's saying is if this XZ is my largest side and I look across opposite, then that would have to be the largest angle. And if I'm comparing it to XY, let's say XY is my smaller, I mean, and we know it's smaller than XZ. So so again, if I look opposite, then that would be angle Z. So since I know XZ, the largest, is greater than the smaller, then I know that angle Y is going to be greater than angle Z. And so all we're going to do is use that relationship, finding the larger or the smallest, to help us order or identify the different parts and compare them. So in this example 2, they want us to list the angles in order from the smallest to the largest. So since we're trying to find smallest to the largest, I got to start off with that smallest part. Well, I look at what's given, and right off the bat, since I know I'm given this angle 105 and it's obtuse, then if I have an obtuse angle in the triangle, the other two have to be acute. They have to be smaller. So that lets me know that right off the bat, this would have to be the largest side because it's opposite the largest angle, okay? So now what I'm doing is I'm going to compare x to 3x. Well, x is obviously smaller than 3x's, right? So then I can see that my smallest angle is going to be D. So it starts off with angle D, then the next smallest angle would be angle C, because that would be opposite the 3x, and because we know the largest is angle E. So what we're just doing here is just kind of labeling our parts and then comparing them and ordering them. So on number 6, if a diagram is not given, then you need to draw and label one. So this is just a little hint. If you don't see a picture, draw and label. So just make a random triangle. Doesn't have to be to scale or anything. We're going to label it X, Y, Z. All right. Then they tell us that xy is 12. So between x and y, I'm going to put the 12 right there. It tells us that yz is 24. So I'm going to put 24 right there. And it tells us that the x is 30. Put the 30 there. Now, they want us to list the angles in order from smallest to largest. So find your smallest side. The smallest side would be here. Look across. So we're starting off with angle Z. So then we go to the next smallest side. The next smallest side is my XY, the 24. Go across. So that will be angle X. And then our largest side, which is the 30, look across, and that would be angle Y. So make sure you look across to find your largest side or largest angle. So if I know the largest side is opposite the largest angle, then if I have two angles that are not congruent, then I could just do the vice versa, the reverse of this. Then, excuse me, then your longer side will always lie opposite the larger angle. So if I know right here, if A, the measure of angle A is greater than the measure of angle B, okay? So then if I go to the opposite side, I would see BC, and so BC would have to be greater than that opposite side of angle B, which is AC, right? So we're just going from in to out. Before we're going out in, now we're going from the inside going to the outside. So now in order to do something like this, we need to know all angle measure, all three. So we're going to use our triangle sum theorem, which says the triangle, all triangles have a sum of 180. So if I know right off the bat, I have 28 and 10, so this is 138. Then I'm going to take that 180 and subtract from it. So this is going to give me 42 in this angle. Now I can compare. So they want us to find the shortest side. And in order to find that shortest side, you're going to have to get that smallest angle. And right there, you see, this is your smallest angle. Let me do it this way. This is our smallest angle. So we look opposite to get the smallest side. This would end up being the smallest side. So our smallest side, we would write FH or HF. Then we go to the next smallest angle. The next smallest angle right here is 42. And we look opposite. And so that would be GF. And then our largest angle is 110, which would give us our largest side is GH, because you have to look opposite. So just like, excuse me, just like you did on, what was it, example 6, if you don't have a diagram, you need to draw one and label it. So we're going to have triangle DEF. Doesn't have to be a scale. You know, angle D is going to be 51. Angle E is going to be 59. And angle F is going to be 70. So they want us to list the sides from shortest to longest. So let me pause and let you have a moment to try to do this and then check your work. Okay, your side should be FE, or you could have said EF. Okay, order doesn't matter. You just have to make sure those two letters. So it goes FE to DF, excuse me, to DE. Okay, DE is our largest. So the thing is, this is important right here. These facts, this relationship with triangles. So if the biggest angle is opposite the biggest side, and you just work down. So you go big to medium to small. And your biggest side is always opposite the biggest angle and work down. Okay? So you're going to have some practice problems in relationship to that to see how well do we understand this from this video. The last thing I want to talk about is when you have inequalities with two figures that are next to each other. So if you look at this figure here, we have two triangles side by side, and they want us to put the sides of the quadrilateral, that is the four-sided figure, in order from greatest to least. Now, in order for me to do that, I need all the angles inside the triangle. So what we need to do is find this angle D, And when I find that angle D, I'm going to focus on this triangle, what is it, BAD? And I'm going to use the triangle sum there. So I'm going to add up our sides. So we have, excuse me, 71 and 50 will give me 121. So that means that this angle would have to be 59 because we want a sum of 180. And then I'm going to find the missing angle in this triangle BCD. Okay. So I have the 60 and the 50. That's 110. So this would have to be 70. So we have a sum of 180. Okay. All right. So the way we're going to do this is we want to find the largest angle to get to my largest side. And so my greatest angle is the 71 right here. And then all I have to do is look opposite to get to that side. So we're starting off with the side AD. That's the largest one. Remember, we're doing the size of the quadrilateral. So like if I go to the next angle would be this 70. And if I look, across for 70 is this segment BD. Now, BD is this inside. If it's quadrilateral, we're talking about the outside. Like a quadrilateral is a quadrilateral because it has 4 sides. So this would be 1, 2, 3, 4. So I can't pick BD because BD is a diagonal. It's inside. And if you look, if I looked over here at angle A, it also points to BD. Okay? So anything in the interior when trying to find the greatest side of a quadrilateral, we can't use. So we're going to not pick BD. So go to the next largest number. The next largest number is the 60. And so I can see that this 60 go opposite. We get DC. So we're going to have AD, then DC. Then our next largest number is the 59 right here. So that would be, our AB. And then our 59, then we would go 50, but we're not going to pick that 50. But if I look at this 50 over here, that would be BC. Okay? So don't pick, when we're doing sides of quadrilaterals, we can't pick the diagonal. You only can pick on the outside. So what I want you to try to do, let's see if you can answer this one. I'm going to go ahead, pause, let you try it, and check your understanding. And then when we're done, we have some problems here. And I'm just going to kind of give you an overview of that. Okay, on this one, I thought you had to order, but no, they just want you to find the shortest side. So you just need to find the shortest, the smallest angle, which is 44, and go across, and it would be side BA. Or you could say AB. Those are both the same. They both are the same. All right, so now that we did this, okay, if you need to rewatch it and get some clarification, go back as you're working through these check for understanding. Please do so, but I want you to take what we did on this video to see if you can problem solve some problems on this worksheet. So this first section, you just want to order. You want to go from least to greatest with their angles. So remember, you have to look at your side links and go across. So in a problem like this, excuse me, you would find the smallest number, like for example, this is the smallest number, and then go across, and that would be my smallest angle. So then we go, the next smallest would be 2.7, across would be angle M, and then angle O. So we're just listing, just like I have here, the angles from least to greatest. Okay, don't forget your angle symbol. Don't just put the letter. And then we're going to do the same thing, vice versa, with the side links. And on the side links, I'm going from shortest to longest. Okay, and so to get the shortest, you have to find the shortest angle. So here's my shortest angle, go across. That would be AD. Then the next shortest would be the 62, go across. That would be DE. And the longest would be the 90, go across. That would be AE. Okay, so that's what we're doing here. And then here it says draw the triangle, label it, and then list your sides. So you want to see if you can do this. It's similar to what we did on the notes. And then here you're answering the question using this figure that they gave you over here on the right. So they want you to, and they gave you all the angle measures, find the longest segment in a specific triangle. So make sure For the say triangle BDC, you're looking at only those angle measurements. And if I want the longest segment, I should be looking for the largest angle and then look across. Okay, so just using your diagram, using your relationships, what you know, to answer. So I want you to get this done. Then you need to take a picture of your notes with these problems. This what was it? 11 problems. And I'm going to check your understanding on looking at how would you apply it, or got through the lesson, the video lesson, got down the notes and the key information, and then let's see how well you do on these problems. If you have any questions, please just hit me up on Remind, or shoot me an email or message on the chat. All right, thanks guys.